Chapter 3. Which terrifying new math? I want you to act as if you would in a crisis. I want you to act as if your house is on fire, because it is. As famously worded by Greta Thunberg during a speech delivered for the World Economic Forum in Davos. The flowers on the slide are called Thunbergia mysorensis, or Mysore trumpet vine, native to tropical India and named after Carl Thunberg, one of Carl Linnaeus' his apostles. I saw these flowers in the botanical garden of the city Prague, where the plant is known as a Thunbergie. Our house increasingly often is on fire. Last summer we have seen unprecedented forest fires across Europe. Wallace Wells, who explored the potential consequences of warming beyond 2 degrees, notes that over the last decades, the wildfire season in the western United States has already grown by 2.5 months. Of the 10 years with the most wildfire activity on record, 9 have occurred since 2000. Many of you have probably seen this photo of a burnt koala on Kangaroo Island, taken by Marius and published in The Guardian. The description read, "The island is considered a Noah's Ark and refuge for animals like the estimated 25,000 koalas that perished in the fires." The Wikipedia page on the bushfires describes that fires raged from June 2019 to May 2020 and had burned an area about 4.5 times the size of the Netherlands. It is likely that numerous species have gone extinct, especially considering that about 3/4 of Australia's threatened wildlife are plants, often with small ranges. In areas where wildfires are a relatively common natural phenomenon, some populations will bounce back relatively quickly, as shown by a citizen science initiative that recorded frog calls. Yet, Australia and California are not the only regions plagued by wildfires. The last years, large parts of the Amazon and Pantanal wetlands have been on fire as well. Historically, such fires have been much more rare in Brazil, and many of the over 40,000 fires likely have been the result of slash and burn, where farmers claim land by clearing the forest with fire. Climate change has likely worsened the duration of these fires. The time-lapse figure by Revelator shows you where you can find the Pantanal and track the number of square kilometers burned with data from NASA. The cumulative area burned is estimated to range between 12 to 16% of the Pantanal. Climate change and biodiversity laws are interwoven, as you probably know already. One mechanism by which climate change leads to biodiversity loss is through the spread of disease. For example, Koch and colleagues found that the Saiga megadeath of 2015 is likely the result of a bacterial infection due to rising maximum temperatures and humidity. This Saiga megadeath of 2015 referred to 200,000 Saiga antelopes dying in a time span of 3 weeks, which was about 60% of the global population at the time. Instead of the spread of a bacterial infection spreading due to higher maximum temperatures, Pounds and colleagues show how the rise of minimum temperatures allow the spread of an amphibian-killing fungus. The cetric fungus is implicated in this extinction of 2/3 of American tropical frogs of the Atelopus family. Beyond species, or entire families, climate change also threatens entire ecosystems. Most prominently is the threat to the highly diverse coral reef ecosystems. That is, corals face a double climate threat, with coral bleaching due to higher temperature and slower recovery due to the influence of ocean acidification over the calcification process of corals, plankton and shellfish. Vrieler and colleagues estimate that preserving more than 10% of coral reefs worldwide would require limiting warming to below 1.5 degrees Celsius, and conclude that there is little doubt from our analysis that coral reefs will no longer be prominent within coastal ecosystems if global average temperatures exceed 2 degrees Celsius above pre-industrial periods. The ocean acidification observed so far is a drop in the pH level from the pre-industrial level of 8.25 to 8.1 or less currently. As the pH scale is a logarithmic scale, this corresponds to 30% or more acidic oceans. The IPCC predicts that the pH level may drop to a value between 7.7 and 7.8 at the end of this century. A study by Hall Spencer and his colleagues illustrates how serious such a drop could be. Hall Spencer and colleagues used volcanic vents near the Italian coast to investigate how different forms of life cope with varying levels of acidity. These vents naturally release carbon dioxide into the sea, creating different pH zones around them and providing a window into the ocean of the future. Their senses of the sea included only species that you could see with the naked eye, in an area that was far away enough from the vents to have a pH level similar to the ocean's average. They counted 69 animals and 51 plant species. As researchers moved closer to the volcanic vents, they could observe the number of species that were still present in areas that had pH levels predicted for the end of the century. A third of the species were no longer present in these acidified parts of the ocean. Amongst the no-shows, there was a mollusk named after Noah's Ark, Arche Noah.